So I just stumbled upon Qiskit and it's kind of blowing my mind. It's this open source SDK for quantum computing, right?
Yeah, it's designed for working with quantum circuits and operators. The potential applications are just incredible.
I know it's like they're giving us the tools to play with quantum states, but how does it actually work? I mean, it sounds super complex.
It's definitely a shift from classical programming. You define quantum circuits, which is a whole different way of thinking about computation.
Right, and I saw that it starts with building a quantum circuit, but wouldn't that be challenging for someone new to quantum concepts?
For sure, it's a big leap. You have to wrap your head around concepts like superposition and entanglement first.
Superposition, like how a qubit can be both 0 and 1 at the same time, that's just mind-bending.
Exactly. And don't forget entanglement, where qubits become interconnected. Changes to one can affect another instantly, no matter the distance.
Wow, that really sounds like science fiction, but how do you even create these circuits in Qiskit?
You start by defining the quantum state you want to represent. Then you use quantum gates to manipulate those states.
I saw an example where they create a GHZ state. It's like combining multiple states into one. How does that work?
You use specific gates like Hadamard and CNOT to create that entanglement. It's fascinating how just a few simple operations can produce complex states.
But it sounds like there's a lot of potential for error in those operations, right? I mean, quantum systems are notoriously delicate.
Absolutely. They're very sensitive to their environment. That's why error correction is such a hot topic in quantum computing.
Speaking of errors, how does Qiskit deal with that? Is there built-in error correction?
Qiskit provides tools for error mitigation, but full error correction is still a challenge. It's an active area of research.
So what about integrating Qiskit with real quantum hardware? That feels like a huge step.
It is. Qiskit supports running circuits on various hardware backends. It's like bridging the gap between theory and real-world applications.
That makes sense, but I wonder, doesn't this mean you have to rewrite your circuits for different hardware?
Exactly. The transpiler does that heavy lifting. It optimizes and maps your circuit to fit the specific hardware capabilities.
So it's not just about writing code, but also about understanding the hardware limitations. That's a lot to juggle.
It is. And that's why education and resources are crucial for developers diving into quantum programming.
I noticed they offer a runtime environment too. What's the benefit of that?
The runtime optimizes how circuits are executed based on the specific hardware, which can significantly improve performance.
That's really smart, but I have to ask, does that mean there are still limitations to what you can achieve with Qiskit?
Definitely, while it's powerful, quantum computing isn't a magic bullet. There are problems it simply can't solve efficiently yet.
That's a good point. It's like we're at the start of a journey and there's still so much to explore.
Exactly. The intrigue lies in what's still to come as research evolves. We're part of this quantum revolution.
I'm really curious about the contributions aspect too. Can anyone contribute to Qiskit?
Yes, they have contribution guidelines, and the community is very welcoming to new ideas and improvements.
That's awesome. It makes it feel more like a collaborative effort. But how do you track issues or bugs?
They use GitHub issues to track bugs and feature requests. It's a common practice in open source projects.
And there's a whole community on Slack for discussions. That's super helpful.
For sure, engaging with others can really enhance learning and problem solving. Plus, Stack Overflow is great for quick questions.
So if someone wants to start with Qiskit, where should they begin?
I'd suggest starting with the documentation. It's comprehensive and offers tutorials to get familiar with the basics.
That sounds like a solid plan. I love how accessible they've made quantum computing.
It really is. And it's exciting to think about how it could revolutionize industries in the future.
I feel like we're just scratching the surface. What do you think the biggest impact of quantum computing will be?
I think drug discovery and complex optimization problems are huge areas. The potential is just staggering.
Absolutely, but I wonder if we're ready for the ethical implications of quantum tech.
That's a critical point. As powerful as it is, We need to consider the societal impacts and ensure responsible use.
Wow, there's so much to think about. It feels like we're on the brink of something groundbreaking.
Definitely. I'm excited to see how it all unfolds and what new discoveries lie ahead.
Me too, let's keep exploring and maybe catch up again as we learn more.
For sure, there's always something new in the quantum world.